The main motive of the lecture is to give you an idea regarding anatomical dead space and physiological dead space. This volume of air remains in the conducting zone and never actually reaches the alveoli. If this physiological dead space is more than anatomical dead space, if this physiological dead space is more than anatomical dead space, what does that last? The dead space volume, ventilation. How much of air is present as in the anatomical dead space? Here dead space means the anatomical dead space. This is around 150 ml into, you can say, 12. Welcome everyone. This is our 10-minute series. Specifically in this session, we will be covering the concept called dead space. So before going into dead space, first of all, we will be covering these two topics. The main motive of the lecture is to give you an idea regarding anatomical dead space and physiological dead space. But beforehand, you need to understand what a tidal volume is. A tidal volume is the volume of air that you inhale or exhale normally. In normal respiration, our muscles, that is the external intercostal muscles and the diaphragm, these are involved. In tidal volume, we define the volume of air. This refers to the volume of air that is inhaled or exhaled during a normal breathing. During a normal breathing. So this value, since we are talking about a volume, this volume is actually, we denote it as tidal volume equal to 500 ml. That is, during a normal inhalation or exhalation, we take in or expel out around 500 ml of air. So graphically we can represent it like this is a tidal volume. So this tidal volume refers to the volume of air that is inhaled or exhaled during a normal inhalation or exhalation, which turns out to be around 500 ml. But see, during forceful inhalation, we can take in some extra amount of air. So if this is a tidal volume, we can take in some extra amount of air during forceful inhalation. This forceful inhalation, we can take in this much volume of air which is extra, that is, we can take the tidal volume plus extra this part, and this is known as inspiratory reserve volume, whose value turns out to be somewhere around 2500 to 3000 ml, that is around 2.5 to 3 liters. So similarly, you can also exhale this amount of air. This is the tidal volume of 500 ml, and by forceful exhalation, you can give out this amount of air. This much amount of air you can expel out by forceful exhalation. This is called expiratory reserve volume. That is the volume of air that can be exhaled by forceful exhalation. Now, reminding you something, when we say forceful inhalation or forceful exhalation, our abdominal muscles are also involved. Fine. So this is the volume of air that can be exhaled by forceful exhalation. You can still see another line. This represents that this is the volume of air. This is always present in the lungs. That is, you cannot exhale it even after forceful exhalation. This is known as residual volume. Now, if I write the values, the value of expiratory reserve volume is around 1000 to 1100 ml, whereas the volume of residual volume is approximately 1100 to 1200 ml. That is, this is the volume of air that you cannot exhale even after forceful exhalation. This amount of air will always stay in the lungs. Now, these are called pulmonary volumes. Now, if I talk about capacities, this tidal volume and inspiratory reserve volume, this represents the total volume of air that you can take in by forceful inhalation. That is the normal tidal volume plus this much extra, the inspiratory reserve volume. This is called inspiratory capacity. Fine. Simultaneously, you can say, or similarly, you can say that the tidal volume plus expiratory reserve volume, this is the volume of air you can exhale by forceful exhalation. This is called expiratory capacity. Fine. Now, if I take into consideration this much part, that is the inspiratory reserve volume, tidal volume and expiratory reserve volume, this forms the vital capacity or respiratory index. This is the vital capacity. That means this is the amount of air you can take in by forceful inhalation and you can expel out by forceful exhalation. If I define it, you will get a more clear idea. Say, the question says, what is the volume of air that you can take in after a forceful exhalation? If I am telling about forceful exhalation, the graph is somewhere in here. Forceful exhalation is done. Now, what is the total volume of air you can take? You can take in this much amount of air that you have forcefully exhaled. Then you can take in the normal tidal volume. Then you can also take in the inspiratory reserve volume. This forms the vital capacity. So, you can define it as this is the volume of air that can be inhaled even after a forceful exhalation. Sorry. Now, if I compare all these three, say the entire one, what is the total capacity of your lungs? This is the inspiratory reserve volume plus tidal volume plus expiratory reserve volume plus residual volume. This is the total capacity of your lungs. This is called total lung capacity. Fine. There is one more capacity, that is ERV, expiratory reserve volume and residual volume. This is known as functional residual capacity. How can you define functional residual capacity? If this is a statement, you can define it as after normal exhalation, that is tidal volume. After normal exhalation, the volume of air present in lungs is called FRC, functional residual capacity. After a normal exhalation, that is up to this much, the volume of air present in lungs is this much. This is known as functional residual capacity. Fine. Now, let's dig into our main topic, that is anatomical dead space. First, you know that in respiration there is a conducting passage and, or you can say, a conducting zone followed by an exchange zone. Now, what is a conducting zone? This is a zone up to the terminal bronchioles. And this is a zone that includes respiratory bronchiole, although this respiratory bronchiole is not given in our book. This is a bronchiole See, there are three bronchioles: initial bronchiole, terminal bronchiole, and respiratory bronchiole. So the respiratory bronchiole is not given, I think, in the NCERT. So this includes the respiratory bronchiole plus the alveolar duct and the alveoli, where exchange actually occurs. During tidal volume, we inhale. During tidal volume, we inhale how much? 500 ml. But out of this 500, approximately a volume of 350 ml is actually available to the alveoli. This 350 ml is the volume of air that is actually available to the alveoli of 500 ml. That is somewhere around 150 ml is still present in the conducting zone. Around 150 ml is present in the conducting zone. This 150 ml is never exchanged. This 150 ml is never exchanged by the alveoli. This is known as anatomical dead space. Fine. So I think the concept of anatomical dead space is clear. That is, this much of air, this volume of air remains in the conducting zone and never actually reaches the alveoli. This is called the anatomical dead space. Now say the alveoli has 350 ml. We will need a concept of alveolar dead space now. Say this is an alveoli. Say I have taken here 7 lobes: 1, 2, 3, 4, 5, 6, 7. So how much of air is actually present here? 350 ml. Just now I have seen. This is the actual volume of air that is available to the alveoli. Now let's say this is a blood vessel or blood capillaries. This capillary surrounds the alveoli. Fine. This is a capillary that surrounds the alveoli. Say somewhere the flow of blood is in this direction. Say somewhere in here, there is an emboli. Emboli, or you can simply say there is a clot. There is a clot within the blood vessel due to some reason. So if there is a clot here, I am taking a case where there is air in the alveoli, but this first and second lobe, they cannot exchange. They cannot exchange. So out of this 350 ml, there are 7 lobes. Say I am taking a case for simplicity. If each lobe gives or exchanges 50 ml, then 50 into 7 will be 350. So if these two lobes are not doing any exchange, why? There is no problem in the lobes of alveoli. There is some problem in the capillary with which the exchange will take place. So these two will remain non-functional. So out of this 350 ml, say each lobe takes in 50 ml. 50 ml each lobe. So this 1 and 2, they cannot exchange. That is 100 ml less will go into the blood. Ideally 350 ml of oxygen should reach here. 350 ml of the air that came into the alveoli should reach into the capillaries. But since these two are damaged, I mean these two are okay, but there is an emboli or clot in the blood vessel, exchange through these two will not occur. So out of this 350 ml, say only around 250 ml will get exchanged and 100 ml cannot get exchanged by these two lobes since this part is not working. This is known as alveolar dead space. Are you clear regarding that? This is known as the alveolar dead space. That is, blood capillaries do not exchange gases with some lobes of alveoli. So there is no problem with the alveoli, but the problem rests within the blood capillary. There is development of an emboli or clot. Fine, this is known as alveolar dead space. So in a normal human, this alveolar dead space, this should be 0. In a normal human, the alveolar dead space should be what? This should be 0. This is a disease, emboli or clot is a disease. But in a normal human, if everything is fine, then the alveolar dead space should be 0. Correct? Now, what is a physiological dead space? This refers to the summation of anatomical dead space plus the alveolar dead space. Fine. In a normal human, say I am taking the case of a normal human. Here, alveolar dead space is 0 because there is no emboli or clot in a normal human, a healthy human. So, we can say physiological dead space is equal to anatomical dead space because this is 0 in a normal human. Fine. Say, if we see the same thing in a different way, if physiological dead space is more than anatomical dead space, if this physiological dead space is more than anatomical dead space, what does that mean? This is the physiological dead space. This means this alveolar dead space is not equal to 0. If physiological dead space is more than anatomical, this means this has some value. It is a case which denotes that alveolar dead space is not 0. Fine. And it is an indicative of what? It is an indicative of emboli or clot or some damage in the capillaries. Clear? Because if there is some damage in capillaries, the alveolar dead space would have some positive value. Accordingly, this positive value plus anatomical dead space is the physiological dead space. So that this physiological dead space as a whole will be greater than the anatomical dead space. Fine. Next. What is minute ventilation rate? That amount of air that comes into the lungs is what? Tidal volume, 500 ml. This is tidal volume into respiration rate. So the tidal volume is what? Approximately around 500 ml and respiration rate is 12 to 16 per minute. So I am taking the respiration rate is 12 to 16 per minute. So this turns out to be, if I am taking the limit of 12, this turns out to be around 12 into 5, that is around 6000 ml, or you can say 6 liter. That is, this is the volume of air that comes into your lungs per minute. Next, the alveolar ventilation rate. How much air is actually available to the alveoli? Leave the anatomical dead space part, 150 ml, that is not available to the alveoli. So this would turn out to be 350 ml into 12, that is respiration rate, which turns out to be around 350 into 12, 35, 350, 400, I think that is 4200 ml, or approximately you can say 4.2 liter per minute. Fine, this is the alveolar ventilation rate. Last, the dead space volume ventilation. How much of air is present as in the anatomical dead space? Here dead space means the anatomical dead space. This is around 150 ml into you can say 12. that turns out to be around 1800 ml, or you can say 1.8 liter per minute. You can simply calculate it by deducting this from this one. This is the total tidal volume, this is the available volume, this is the unavailable volume that is exchanged per minute. I hope through this session you got a clear cut idea about anatomical, physiological and alveolar dead space as well. Fine. So keep following the channel for some more interesting videos regarding the same topic within or under 10 minutes. Fine.